Hello, Rohan. How are you doing?
I'm doing good, sir. How are you doing today?
Very good, very good. So, yesterday we learned about the application of tangent ratio to solve many real life situations. Did you understand that lesson?
Yes, sir. I was able to understand the lesson and how it was used in the real world, along with elevation and descendant of an angle.
And angle of depression, correct. So, we solved actually height and distance questions using the tangent ratio yesterday, and all the concepts are clear. But there are two other very important applications not really dealt with in most of the books. So, in my new upcoming book on trigonometry, I have in at length dealt with this particular topic, and we'll now see how do we find the wingspan of the birds flying above us from the angle at which we see the bird, right? So that is a very interesting example. We call it the subtended angle. So we'll see that. And another very important example is finding angle between the lines. Now, that is a very good question for many competitive exams. And therefore, I like you to focus on these two things now, and that will help you to gain upper hand in competitive exams like Olympiad and Math Kangaroo. Okay. So let me share with you the screen, and then from there we'll continue. So Rohan, can you see my screen?
It's starting to start. Yeah, now I'm able to see it.
So this is example 11. Yesterday we actually did example 8, which was about height and distance, right? 3D figure. We did this yesterday. Now let's continue forward. Can you please read the question?
Determine the angle which bald eagle with wingspan of 2.5 meters subtend at an observer eye flying 100 meters directly above him.
Correct. So, bald eagle has a very wide wingspan. It is about 2.5 meters, right? So, if a bald eagle is flying way above in the sky, we have the standard wingspan. From there, we can say, well, it is 2.5 meters. So, that is from A to B shown here. That's the wingspan. And it is flying at a height of 100 meters. That is the estimated height for us. Right. We need to determine the angle which the bald eagle makes. So the full angle theta, we are divided into two portions written as theta by 2 in this particular diagram. So basically, we have to find the angle theta which a person looking at the bald eagle will make. Do you understand? So this is the bald eagle, and that's the angle which we want to figure out.
Okay,
How
sir.
much should be that angle? Now, we could also put this problem in a different case. There is some other bird flying, and if we know this angle, correct, and the height, we can find the wingspan of the bird. You get the idea.
Yes, sir.
So either way, we could do it. Well, if you know the angle and the wingspan, you can also find the height of the bird. So many different ways we could have the same question. Correct. So the idea here is we could actually, as you can see, a big triangle is formed. But if I draw the right bisector in this particular case, because of the symmetry, it will divide AB into two equal parts. So M is my midpoint, right? So this 2.5 meters of wingspan now can be written as half of 2.5 as a distance M to B, right? So we know M to B, we know 100 meters, correct? Which
Yes,
is
sir.
the distance. And now we can use the tangent ratio, which is opposite over adjacent side,
Yes,
correct?
yes.
So we have the tan theta, which is basically equal to the ratio of opposite side to adjacent side, correct? So using this ratio, we can find the angle theta. In this case, since we dropped a perpendicular, we have bisected the angle also. So we'll measure this as theta by 2, multiplying by 2. Rohan, do you understand the situation? Now, can you tell me how are you going to solve this particular question?
So, sir, by looking at that, since we have AB as our whole, which is equivalent to 2.5 meters, sir, the
Yeah,
best way would be dividing it in half. That way we could solve for one triangle.
correct.
So that's 2.5 divided by 2 would be 1.25 meters. So
Right.
AM and BM would be 1.25 meters.
Right.
And I think after that, we would just do a tan to find out one side of
Correct.
theta over 2.
Yeah, because the total angle has been divided to two equal parts. So we have theta by 2. So we can get tan theta by 2 as the ratio of MB over M to O. We know both the sides, and therefore we can find theta by 2 as tan inverse of this, which comes out to be as 0.7161 degrees. Very small angle, correct? Now you could multiply this by 2 to get the total angle, which is 1.43 degrees. You get the idea? So we can
Yes, sir.
measure this angle, which is our angle subtended by the wingspan. So now you understand the word subtends, form,
Yes, sir.
get to, right? That is what it is. Now from here, we could actually generalize the situation, right? As you can see here, what we did basically was that this wingspan is twice, if we complete this particular triangle, then in that case, we know this is half of the wingspan, right? Let's do it like this. We know this part is half of wingspan, correct? This is also half of wingspan. So in this particular triangle, we have tan theta by 2 as equal to opposite side, which is half of the wingspan divided by the height h, correct? So we can isolate W from here, which is equals to h, and then that 2 also gets multiplied. It's better to write the numbers before the variable. 2h times tan theta by 2. Is that clear to you? So we have a
Yes, sir.
formula, and this is the formula which you could always use to relate the wingspan with height and the angle subtended. Do you see that formula now?
Yes, sir.
This formula can be rearranged to find the height as a ratio of half of the wingspan divided by tan of half the angle, or you could use it to find the angle theta, which will be twice tan inverse of half of wingspan divided by height. So you get these three related formulae for solving such a situation using tangent ratio. Is this concept clear to you?
Yes, sir.
Correct? Very important. Now, once we have this with us, now we can easily solve questions related to it. Can you please read example 12?
Determine the height above the ground from which bald eagle wingspan of 2.5 meters will subtend at angle of 1 degree to the observer directly below on the ground.
Correct. So this time we have to find the height. We are given is bald eagle whose wingspan is normally 2.5 meters and the angle subtended is 1 degree. So we need to find how high the bald eagle is flying. You can apply one of these formulas, the height formula, right? We know the wingspan 2.5 divided by 2, tan of the angle is 1 degree, 1 divided by 2. You can do the calculations and find the height and approximate it to round 2 meters if you want to. So we get 143.2 meters, correct? If you want, you can also round it to the nearest tens of meters. You can say approximately 140 meters. You get the idea.
Yes, sir.
So from the angle, we can now find the height at which the bird is flying above us. You get the idea. So very, very powerful set of equations which you can always use while moving around. You understand in nature, and you can estimate so many things and appreciate them. You get the idea.
Yes, sir.
Perfect. So is this absolutely clear to you?
Yes, sir.
Okay. We'll take up the next example, which is based on angles formed by the lines. Last time during our class, I did tell you that tan theta is like slope of the line, right? Y equals to mx plus b. And
Yes,
tan
sir.
theta gives you the slope, because basically, what is y equals to mx plus b saying? M is the slope, right? M is change in y over change in x, correct? So basically,
Yes, sir.
gradient, right? Or slope, right? Rise over run. So in any triangle, this is the change in y, correct? And that is the change in x, correct? But
Yes,
it is
sir.
also opposite over
All right.
adjacent.
Yes, sir.
So that means it is tan theta. So m is same as tangent of the angle theta, which the line makes with x-axis. You get the idea.
Yes, sir.
So these are two related things. Can you please read the first example related to the angles formed with the lines?
Find the acute angle formed by the following lines and the x-axis.
Correct.
Round to the whole numbers.
Perfect. First one, y equals to x minus 1. So what will be the acute angle for this particular line? Y equals to x minus 1. Can you tell me?
It would be,
You have to look for the slope, right? Yeah,
yes, sir.
slope is 1, right? So tan theta is 1. So theta is tan
45
inverse of
degrees.
1, which is 45 degrees. Do you see that?
Yes, sir.
You get the idea how easy it is? Isn't that meaningful? So we do have a line now, y equals to x minus 1. Let me just sketch one quickly here for you, right? So that is the line. And definitely, this particular angle now is 45 degrees. Is that clear to you?
Yes, sir.
Does make sense? That is how useful this particular relation is. We have all of a sudden related trigonometry with the coordinate plane and the lines which you know so well. You get the idea.
Yes, sir.
That is a huge connection. And this can actually help us to solve many different difficult questions and relate them. Perfect. So can you answer the second question, which is when the line equation is y equals to 2 over 3x plus 5, how will you find the angle between this line and the x-axis?
So, sir, for this one, I would do tan inverse.
Yes,
So that would be 2 over 3. And I got 33.69. So I just
perfect.
rounded it to 34.
You get the idea, right? So similarly, it is very easy to do for any equation. Now for the part C, which is 2x minus y equals to 6, tell me what is the slope?
I got the slope. So the slope is 2. So I got the angle as 63 degrees.
Very easy now, correct? How it is fun. Relating the trigonometry with the lines, so easy, right? So slope m is tangent of the theta. That is the basic definition of tan theta, right? Okay. So now, can you do example number 2?
Find the acute angle formed by the line 12x minus 13y plus 6 equals 0 and the y-axis.
Not x, but y-axis. So if the angle with the x-axis is, let us say, theta, what will be the angle with the y-axis? 90 minus theta, correct? Because both the axes are at right angles. You get the idea.
Yes, sir.
So if you use tan theta, you will actually calculate the angle which the line makes with the x-axis. And if you do 90 minus that angle, then you get the angle which the line makes with the y-axis. You get the idea?
Yeah.
So that is what we have to do. We have to just find the complementary angle to get the answer. So can you please, so first step will be to write the equation in terms of slope and intercept form so that you know what slope is. And then tangent of that will give you the angle relation. And then 90 minus that will give you the angle with y-axis, correct? So can you please follow the steps and tell me, how will you do it and what is your answer?
So, sir, first what I would do is I would change the sum of formula of a plus b plus c equals 0 into y equals mx plus b.
Correct.
From there, whatever I have identified, I would first solve for x. In that case, it was 12 over 13. So I would do tan inverse.
So
I mean, yes,
12x minus 13y plus 6 equals to 0. I took the, I isolated y basically. When I isolate y, I get slope as 12 over 13. And so tan theta is 12 over 13 and theta is tan inverse. So we get an angle of 43 degrees. So that is the angle theta, right? Well, we need to find the angle with y-axis. Now you can see in this particular diagram that the other angle will be 90 minus theta. So we have to do 90 minus 43 degrees to get the angle with y-axis. These are vertically opposite angles, so both will be equal, correct?
yes,
so when you
sir.
do that, what do you get?
47 degrees, sir.
So 47 degrees is the angle here, which the line will make with the y-axis. You see how simple it is?
Yes, sir.
Very interesting. Very, very interesting. So that is the line, and that is how we could actually solve such questions. Now we could have set of lines. We can have more than one line. So if you have more than one line, then the question could be find the angle between the lines, correct? Now, can you please read this particular question and tell me how will you solve this particular question?
Find the acute angle at which these sets of lines intersect. Y equals half x plus 1 and y equals 3x minus 1.
Correct. So tell me how will you do it?
So first we have to solve for x, so that would be
Okay, I will explain. So Rohan, let's look into the first line, which is y equals to half x plus 1. The diagram is before you. Half x plus 1 means slope is half and the y-intercept is plus 1. So that is the line which is half x plus 1, right?
yes, sir.
The other line is y of 3x minus 1. Minus 1 is the y-intercept. So the line which is higher slope of 3, is shown in blue, is the 3x minus 1. The angle between them is the angle shown here, which is given to us as phi, right? That's a Greek symbol phi. We need to find that particular angle. How
Okay.
do we find it? So the two lines will give you the two angles they make with the x-axis, correct? So you can find
Yes.
theta 1, right? So theta 1 is basically equals to tan inverse of the slope of this particular line, which is half, correct? And theta 2, which is tan inverse of slope of the other line, which in this case is 3, right? So we get theta 1 and theta 2, correct?
Yes, sir.
We need to find the angle phi, vertically opposite. It is the third angle within this particular triangle. And from the external angle, we know that theta 2 is sum of theta 1 and phi, correct? And so phi will be what? Theta 2 minus theta 1. Does it make sense?
Yes, sir.
So once you have those two values, you can always write down. So basically it is tan inverse of 3 minus tan inverse of half, which will give you the angle which the two lines are going to make. Is that clear?
Yeah. Yes, sir. So in total, I got 45 degrees for phi.
Calculated. Oh, very good. You calculated also. That is what I also got. So you must have done the right calculation. Perfect. Good job. So you can see how beautifully, just with the tangent ratio, we could actually solve so many different types of questions. Were you ever aware of such things?
No, sir. I wasn't.
Yeah, there are so many applications. These are the major applications which we do using just the tangent ratio. Now, when we combine tangent with sine and cosine and multiple angles, we can actually solve very, very difficult real life situations. Anything to do with angles and sides, we can do it, right? So that's what it is. I hope you have understood today's lesson. I would like you to summarize today's learnings. So, can you explain about the thing which we started with? That is, we started with the tangent ratio, correct? And took up some applications. So from here, now, can you explain what did you learn of using tangent ratio to solve many examples related to real life situations in your own
So
way?
overall, in this class, I've learned a lot about how real life experiences of using tangent ratios,
Mhm.
remodeling formulas based upon questions, and also solving questions with multiple angles.
Mhm. Right.
So
So we actually understood many other terms which are related. For example, here you can see angle of depression, angle of elevation. So they help you to solve height and distance questions, right? The formula on the right hand side, which I have given here in the boxes, will help you to find the angle in different conditions which relate height and distance, correct? So we took up many different situations. The basic situation is we have a simple triangle, which is a right angle triangle shown to you. You could find height, distance. You have a relation with tan, which is tan theta is height over distance, right? So if two are known, the third one can be figured out. So that is the whole basic. The second example we took with the help of a badger and a honey bird, right? And in that case, if you know we cannot really measure exact distance from one object to the other. then we might be in a position to measure a distance between the 2 points and from their angles to the object as shown here. So what we're trying to say here is that we have an object which is inaccessible. That means there could be a river here, right? So you cannot really measure what is the distance of the object's base to the point on which we are. Let's say there's a river and something is across the river. Then on the other side, we could have a baseline. From a baseline, we can find the two angles of elevation to the object that can help us to calculate the height of the object and also the distances related with it, correct?
Yes, sir.
We also saw how do we solve questions related to finding height of different objects. So from a small building, for example, we could find the height of the bigger building. It could be a tower also or anything else, correct? Just by finding angle of elevation and angle of depression from a position known, we can find the height of the other building. We could also find the height between the objects. For example, there is a bird flying over another bird, or an aeroplane flying over another bird, or a plane going over a tower. So we can find the distance of the plane from the top of the tower using tangent ratio as we did in those examples. Well, if the objects are inaccessible, we mean what? Finding height of the mountains, right? These are inaccessible objects, correct?
Yes, sir.
Even planets. So inaccessible objects. On the earth, we can have two reference points. And from there, if we get the angle of elevation, then we get the height of that inaccessible object. Mount Everest height, if you have to find, then on the plane of Ganges, you can choose 2 points, find the angle of elevation. Since you know the distance between your 2 points and the angle of elevation, you can find the height of Mount Everest also from a very, very far distance. You get the idea.
Yes, sir.
That's the beauty of tangent ratio, right? We actually today extended the same thing to subtended angles. Now, this is the topic which is relatively new. I haven't seen really this topic in most of the books, and therefore I have included this in this version of my book, which will be soon released. So we know the wingspan of the birds. It is kind of standard, right? Any bird, you can look into the reference, you know the wingspan. Now, the thing is, we may have to estimate how high the bird is flying. You will think, how will you find the measure of angle? Well, there are instruments which can help you find the angle between the two objects. You get the idea?
Yes, sir.
So we could use those instruments and find the angle between 2 points. So in this case, the angle is known. We can now definitely find the height using the standard wingspan. You get the idea? So once we do all these calculations, you can see some related formulas can be derived, and these formulas can be used to do fast calculations many times. The last example which we took into was the case when we talk about lines. Now, lines is very important. In many subjects, we have to, there's a curve. In that case, we can have a tangent line on the curve. You get the idea? And that gives you a lot of information about the curve itself. Now, relating the lines, the equation of Cartesian planes in line, with the polar equations, or you can say the trigonometry, becomes a field which is very powerful. And that is the power which you are seeing here, foundation for that. You get the idea? We have
Yes, sir.
related tan theta with the slope itself directly. That's the beauty. And now you can find angle between any two lines, since we know that tan theta is the slope. And that is the angle which the line makes with the x-axis. In my questions, you must have noticed I've been writing acute angle. Well, of course, we are measuring one of the two angles. The other angle will be obtuse. You can see that, right?
Yes, sir.
So we are just worried about the acute angle. We can actually define the line. And from the acute angle also, right? Why not? Take one of them. So that is the whole idea. So I hope that makes a lot of sense to you, right? So now, I would like you to explore further. Look into some very good books, and now you are in a position to solve any question, which is basically a right angle triangle, using just tangent ratios. I hope you find it interesting. I'll also share with you some of my questions on this, okay?
Thank you a lot, sir.
Okay, then we'll end the class here, and I'll share with you a playlist in which I've got many questions related to the topic which we did today. In the next class, we'll talk about sine and cosine ratios, right?
All right, sir.
Okay, then. Have a great day. Bye.
Thank you.
Thank you.
Goodbye, sir.